Camping out is a ball. Even though we live in a modern world, we can still have the experience of living the way people did many years ago. There are a lot of things we have today that people didn't even have throughout history, like TVs, or radios, or even cars. But here's a tool that's been around for hundreds of years, the compass. It's helpful for finding your way if you're camping or hiking. The amazing thing is what's inside a compass, a magnet. So, how do magnets work? It may seem kind of mysterious, but, well, that's what we're going to find out today. So get set, because here we go. Sometimes when I go to the fridge for a cold drink, I like to leave a little note on the door. Nothing too important, just a funny little face for the next person to see. The neat thing, better than my drawing, is how I get the note to stay on the fridge door. Any ideas? Not with tape. No, not with glue. You got it, with a magnet. You've probably played with magnets before, right? But have you ever wondered what makes them stick to things? This is a friend of mine who calls himself Magnet Boy. He's showing us one of the first things we'll all learn about magnets. They stick to some things, but not to others. When we say that a magnet sticks to something, what do we mean? Well, when a magnet gets close to some things, the object and the magnet pull together. They attract. In fact, that's what a magnet is, an object that attracts certain kinds of things. Magnet Boy likes to use a big magnet shaped like a horseshoe to see what kinds of things are attracted by the magnet. It's pretty easy to see that magnets mostly attract things made out of metal. Things like this mailbox, or a fire hydrant, a metal pole, or this car. These are attracted to the magnet because they are made of certain kinds of metal, most often iron. There are lots of things that a magnet won't stick to, like a tree, or a dog, a head of lettuce, or a person. Magnets come in all different shapes and sizes. We've already seen magnets shaped like a horseshoe, but there are bar magnets that are long and flat, and round magnets, like the ones on your fridge door. But no matter what they look like, all magnets have something in common. They all have two ends, called a North Pole and a South Pole. Sometimes they're marked and sometimes they're not, but all magnets have them. If you play with more than one magnet, you can see that sometimes they stick together. They attract. And other times the magnets push apart. They repel. This can make magnets do some pretty funny things. There are a couple of simple rules to remember about magnets. The first rule to know is that opposites attract. They usually say that about people. I guess that's true sometimes, but I can tell you it's always true about magnets. That means the North Pole of one magnet will always be attracted to the South Pole of another magnet. North Pole and South Pole are opposites, and whenever you have two magnets that stick to each other, you know it's the north of one touching the south of the other, because opposites attract. Rule number 2 goes like this. North and north are alike. South and south are alike. We call them like poles. The poles that are alike push away from or repel each other, so we say that likes repel. When the North Pole of one magnet gets close to the North Pole of another magnet, they repel each other. The same goes for the South Poles when they get near each other. likes repel. My friend set up these vacuum cleaners and a bunch of ping pong balls to show you how opposites attract and likes repel. Watch this. The vacuum cleaner with the plus sign is attracting the ping pong balls with the minus signs. Opposites attract. I love this part. Now, watch what the vacuum cleaner with the minus sign does. It shoots out the ping pong balls with the minus signs. Likes repel. No matter what we do, opposites attract, likes repel. It's as simple as that. So we've already learned some important things about magnets. First, magnets attract things that are made out of certain metals, like iron or steel. Also, we know that all magnets have a north pole and a south pole. Plus, we learned the rules of how two magnets act when they are close together. Rule number 1, opposites attract. Rule number 2, likes repel. One thing I used to wonder about magnets is this. How can a magnet make something move without ever touching it? Well, I learned that it's because of something called a magnetic field. The cool thing is that a magnetic field is actually an invisible force that surrounds all magnets. I know it sounds like something out of a movie, but it's true. Even though a magnetic field around a magnet is invisible, with a little help you can see what it looks like. These are iron filings, little bits of metal. If you put some on a piece of paper and hold a magnet underneath, the iron filings are attracted to the magnet. You can even move them around and make designs. To get a better look, lay a magnet down flat and put a piece of paper over it. Now sprinkle the iron filings over the paper. Shake the paper just a bit, and they'll line up in the shape of the magnetic field. Here's a drawing of what a magnetic field would look like if you could really see it. For something to be attracted or repelled by a magnet, it has to be close enough to be in the magnetic field of the magnet. That's how magnets work without actually touching an object. So now you know that certain things, like some kinds of metals, are attracted to magnets. Well, here's a fun way to find metal in a place you'd never expect, in your breakfast. And we'll use what we know about magnets to do it. So here's what you'll need. A large bowl or beaker, water, a large plastic bag that you can seal, a strong bar magnet, a magnifying glass, some paper towels, and, here's the key, iron fortified breakfast cereal. It has to say 100% of the minimum daily requirement of iron on the side. And remember, this is an experiment, not a meal, so no eating the supplies. First, put about 1 cup of the cereal into the plastic bag. Now squeeze out all the air and seal the bag. Now, crush the cereal in the bag with your hands and pour the crushed cereal into the beaker. Now make sure to pour plenty of water into the bowl, more than enough to cover the cereal. Next, wipe off one end of the bar magnet, and it doesn't matter if it's north or south, with a tissue, and place it into the mix and start to stir. Now be patient, because you'll need to stir for at least 10 minutes. You may want to take turns. Now, slowly remove the magnet from the mix and let the water drip off. Don't shake it. Use the magnifying glass to look closely at the end of the magnet. What do you see? If you look very closely, you should see tiny pieces of iron sticking to the magnet. For a better look, lightly wipe the magnet on the paper towel. Use the magnifying glass to look at the tiny specks on the paper. Do you know what happened? Well, just like the box says, the cereal actually has iron in it. believe it or not, iron is an important nutrient for our bodies. That's why they add it to cereal. And we've already learned that many metals, like iron, are attracted to magnets. By stirring with the magnet, you actually pull the tiny bits of iron right out of the cereal. You just proved that some metals, even tiny little pieces, are attracted to the pull of a magnet. Now you might be wondering something like this. Okay, so magnets attract certain things like paper clips and iron filings in cars, but why not everything? What makes these kinds of metals so special that they are attracted by a magnetic field? Good question, and it's a pretty tricky one, so let me see if I can make it easy. Everything in the world, a kitten, balloons, a windmill, or rollerblades, they're made up of very tiny things called atoms. So tiny that they're impossible to see. So tiny that there are billions of atoms just on the head of a pin. Think of it this way. Let's say that each of these dominoes is an atom. See how they face in many different directions? They're not in any special order. Well, that's how atoms are in most things. No special order. But it's different with magnets. If you could see the atoms in a magnet, you would see that they are all lined up in a very neat order. Something like this. And this is what creates a magnetic field around a magnet. In metals that are attracted by magnetic fields, the atoms start out scattered, pointing in all different directions. But when a magnet gets close, the magnetic field pulls all the atoms so that they line up in all the same direction. So the atoms in the metal become like the atoms in a magnet. In other things that are not attracted by a magnet, the atoms never line up, they just stay scattered. So that's the key. In magnetic things, the atoms are able to line up facing all in the same direction. In things that are not magnetic, the atoms don't line up.